A very good day to all the students. My name is Einstein Pillai Sankaran. This is my 5th lesson for organic chemistry. I have prepared this lesson specially for the students who are taking IGCSE Chemistry 0620 or 0654 Coordinated Science. This is our second lesson for alkene. Previously, I've made a few lessons in organic chemistry. I hope you can watch that in advance before you follow to this lesson. Let me show to you. So this is my channel, Einstein Pillai. You can subscribe and you can follow all my lesson, chemistry lesson, all for 0654 and 0620. I have previously organic chemistry alkene 1, and today it's a continuous from that lesson. So in our previous lesson, I have left you with one question that is basically drawing alkene. So let us check today our understanding with that question. So you have alkene, the first one is drawn for you, and the molecular formula is written for you. Full structure formula is also drawn for you. So you are asked to do for the rest of them. Let us see whiteboard and learn together how to do this quickly without memorizing it. Okay, so when we have all of these, okay, so without memorizing it, what are the first technique that I would use is always I would like to draw. So we know that all alkene have one double bond. So when we draw the first one, the first alkene, we draw one double bond, and we can fill out the rest with hydrogen. Therefore, we know the formula of this is actually C2H4. Now, when we go to the next one, propene, you can draw 1, 2, and 3. So again, the same thing, make sure one of them are double bond, and you fill up the rest of the carbon with hydrogen. So we can calculate again. C is 3, H is 1, 2, 3, 4, 5, 6. And you can keep doing the same thing. Okay. Okay, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. And you can keep on drawing hydrogen. Okay, and every time you do the same thing, you can come up with the formula basically C4, H8, C5, H10, and C6, H12, C7, H14, C8, H16, C9, H18, and you can see a trend. The trend would be every time when we have C is N, H is 2N. So this is general formula of alkene. So this is the technique we're going to use. We need to draw a few of them, and we can get the formula, and we can see a pattern here. Okay. So let us continue. That is the homework for the previous lesson. Okay. So the next one, if you have done, let me show to you. Okay. If you're done with that, properties of alkene homologous series. Just like alkane, all alkene have the same functional group. In this case, the functional group is double carbon bond, as you can see, this whiteboard. They have similar chemical properties. They show a gradual change in their physical properties. They have the same general formula just now, Cn, this to N. Each member of the series differ from the next by a carbon hydrogen 2 unit, basically CH2. Okay, so this is for alkene. Now, all alkenes are insoluble in water. As you all know, it's all made from petroleum. They all burn in the air, are flammable. Alkenes show gradual trend in the following properties: melting point and boiling point, density, viscosity, and flammability. So, if you can remember how we have learned in the previous lesson, how to remember all of these points in one shot. Are you? So, if you remember my tricks, the melting and boiling point of the alkene increases as the molecular size increase. The density of alkene increases, the molecular size increase. The alkene becomes more viscous, more difficult to pour out as the molecular size increases. As the molecular size of the alkene molecule increase, it is more difficult to burn this alkene. Huh? So I usually draw and represent these ideas, okay, using a very simple technique that when the molecule is small, I always remember it is as a small mouse. So this is like a small mouse. Okay, mouse is smiling here. And then a bit larger would be like a buffalo or cow. And when the alkene is getting larger, I would even think of that as a large elephant. Okay, so you can see as the size is increasing, the melting point and boiling point, of course, to burn them would increase. So this is the concept. You take a lot of energy, a lot of temperature to burn the elephant compared if you want to burn a cow or a mouse. In the same manner, when you think about density between these three animals, when you throw them out into the water, which one will sink? The elephant will definitely sink. It's too heavy. Okay, the alkene become more viscous. They're more difficult to pour out. So between these three, which one can usually move very slowly? As you can see, elephant moves slowly compared to cow. Cow even moves slowly when you compare to the mouse. Because the size is smaller, they can move very fast. All right, so this is the concept. The last one, as the molecular size increases, it's difficult for them to burn. So if you want to burn them, which one is the most easy? This is the most easy, very small. Very short while, you can burn this little mouse. If you want to compare it, let's say burning a cow, let's say you're going to make a barbecue, it's going to take longer time. Just imagine how long it will take for you if you want to make a barbecue of this elephant. My God, very, very long, all right? So this is a technique to remember them. By having an understanding, smaller the molecule, okay, is more or less represented like a small mouse, larger molecule representing a large elephant. So this is a technique that I use to learn about them. Now, combustion. So just like alkane are also used as a fuel, and it's a good combustion fuel. So with sufficient oxygen, it produces carbon dioxide and water. Incomplete combustion produces carbon monoxide or carbon. and water. So let us look at the board, how to learn to write this equation without memorizing it. So let's say we have pentene here, okay, and we are going to burn this pentene. So there are going to be three scenarios with a complete combustion, okay, complete combustion. Then we're going to have incomplete combustion. So I'm going to use the same pentene. So you may think by now, pent referred to 5 means this carbon number 5. In all the combustion, whether it is complete or incomplete, always there's a presence of oxygen. So we produce here, over here we produce carbon dioxide and water. Over here we produce carbon monoxide and water. Over here we produce carbon and water. Okay? So without memorizing, let us see how to write the equation for combustion of alkene. So guys, the first thing, I look here on my left hand side of the equation, I have 5 carbon. So I put a 5 in front here. I have 10 hydrogen. I make it to become 10 over here. Okay, so I have basically 5 oxygen here and 10 oxygen here. Basically, that is 15 oxygen. All right. So I only have 2 oxygen. Therefore, I know that if I have 2.5, sorry, if I have 7.5 over here, times 2, I get 15. So it is complete. But we know that when we write the chemical equation, it must be a round number. It cannot have any fractional. It cannot have half. So when I multiply everything with 2, 7.5 times 2, 15. 5 times 2, 10. And over here, 5 times 2, 10. So I settle this equation. Okay. So let us do the second one. Same here. I look at my left, I look at my right. 5. Okay. And I have here 5. All right. So now how many oxygen I have here? I have 5 oxygen. Here I have 5 oxygen, 10. So I put here 5. And the last one, same concept. I have 5 carbons. I put here 5 carbons. I have 10 hydrogen. I put here 5. Okay. So again, I look here. I have 5 oxygen here. And I have 2. So what multiply by 2, I can get 5. We know that I can multiply 2.5. But we know again, we cannot put anything in the form of fraction. So I multiply everything with 2. So this is where my equation stands, and this is the technique that we're going to use without memorizing it. Okay. So guys, both alkane and alkene can burn with the presence of oxygen, either complete combustion to produce carbon dioxide and water. Incomplete combustion might produce carbon or sometimes carbon monoxide and water. The only differences between them would be alkene burns with more smokier flame than alkane with similar number of carbon. Let's say over here I have pentene and pentane. Pentene would burn and produce more flames, okay, more smokier flame because it contains higher percentage of carbon. So it produces more black color carbon soot. Now, the next one, if you remember, in alkane, the only reaction that you can go through is actually substitution with the presence of UV light. Here, alkene can go various reaction because alkene is having a double carbon bond, all right? So alkene usually go through addition reaction. So in an addition reaction, carbon-carbon double bonds become a single bond. Earlier in alkene, it is known as substitution because you already have all complete single bond. So we just substitute one of the atom with another element. But over here, they're having a double bond. The double bond is breaking, becoming a single bond. So as you can see, in this diagram, I have this carbon double bond. It can be any type of alkene family. When you react with another, okay, compound here, each part of this compound will join into this carbon bond and breaking them, making it become a single carbon. So making them to become an alkane. So there are three types of reaction. Addition reaction for alkene that will be covered up in our topic. One is hydrogenation. Addition of hydrogen to alkene. Second is bromination. Addition of bromine to alkene. And the third, hydration. Addition of steam to alkene. Okay, so let us go through it quickly. So in hydrogenation reaction, at 200 Celsius and in the presence of a catalyst such as nickel, alkene can react with hydrogen to form alkane. So it depends, guys. If you have propene, it becomes propane. If you have butene, it becomes butane. If you have pentene, it becomes pentane. It becomes the correspond alkane. Okay, the alkene changes into the corresponding alkane by just adding an hydrogen. Okay, so this process is called hydrogenation. The two conditions is it require a specific temperature about 200 Celsius and a catalyst, usually a nickel. Okay, so this is something very new. This is also a method used to change unsaturated to become a saturated hydrocarbon. For an example, when we have an oil, we like to change it to become a margarine. So this is a process that we use in the industry. The next one is bromination. If an alkene is added to a solution of bromine, the reddish brown color disappears. So bromine is having a reddish brown color. The moment you mix with alkene, the bromine color disappears because bromine react with this alkene to form a new compound. So for any alkene, it's the same thing is going to happen. Is it ethene, butene, propane? So guys, this is a test that we use to differentiate alkane and alkene. Let's say you have in a test tube alkane and a test tube alkene. Both of them are colorless. Both of them have not any specific smell. Okay. So how to detect which is alkene, which is alkane? This is a test that we use. When we put a few drops of a bromine water for both of these solutions, alkene would change very quickly the color of the brown bromine to become colorless. Whereas in alkane, it is remain brown. So we know, oh, this is an alkane because the brown color does not disappear or change. So this is a test that they use to identify alkene and alkane. So I hope you can remember, take note this. Okay, this is why I put a smile for you. The last one, hydration. Okay, ethene can react with steam to produce ethanol. So guys, in the industry, this is a method to produce ethanol and other type of alcohol. It's called hydration, adding a molecule of water. So ethene become ethanol. Propene become corresponding propanol. Butene become butanol. So these are all alcohol. This is how alcohol are usually made in industry. So that condition again, it require 300 Celsius. And in this reaction, you also need to have a very specific pressure, which is 60 atm. And the catalyst used is a phosphoric, okay, 5 acid. So this is very interesting, how to change an alkene to alcohol. So guys, all this reaction, hydrogenation, bromination, and also hydration, all of these are known as addition reaction. So it only happens in alkene because the double bond can be changed or converted into a single bond. Okay, so I hope you don't need to memorize. As long you understand this concept, what is happening, and as we go through, we will learn again and again a very simple way to remember all this equation, okay, and learn how to come out with them. Okay, my question for today's last class: can you make a mind map for alkane? So if you are not sure about alkane, go back and watch my early videos. Then can you make a mind map for alkene for today's learning? And finally, can we combine both mind map and see the similarity or the differences and learn together? So I leave these 3 questions for you, and I hope to see some answers in the next lesson. That's all for today. Bye bye for now.